Welcome back, everyone, to part 2. If you'll notice, we are still approaching the moon here, but we are rapidly approaching, and I've found a nice little crater that actually has appropriate lunar geological features. So I figured out it'd be a nice place to land. And we also have nice lunar cavern and canyons over to starboard. And a nice barren... Ooh, looks like we just hit an eclipse. Something must have gotten in the way of our sun. I wonder what that was. And we're about 1.5 kilometers approaching. We're going to slow down. Ah, there's our planet. It's amazing. Alright, we're going to put it down so that way we can explore a little bit more. So I need to find my landing gear. And we are going to try to land on the crest
landing gear deployed
of this crater. If you can notice, we have a 25-degree declination angle, so it's just like an aircraft pip and a HUD. And also at the bottom right of my HUD, you can also notice that we have degree angles that correspond with latitude and longitude. I'm sorry, latitude and longitude with this corresponding moon. And it's also a nice reminder that we have 0.09 gravity. And it looks like we have a nice place to land, so I'm just going to bring it straight down. And we've successfully landed. And here comes our planet again. We are orbiting this planet every 30 seconds. So that's why it seems so fast. But it's just not simply enough fun just to sit on any body that you want to in a simulator. You can always get out and explore it. So we have a rover that we can get into. If I look down here and we say, if I look down here and I say deploy, we can move along. Not sure why we're speaking Spanish. But we can move along any surface in this simulator and explore, mine, farm, find a habitable place to live, anything that might suit us. But then also occasionally you get a lunar eclipse. Here we are at the very edge of our crater, just down below. And if I were to look around, we can see our sun, Epsilon Indi, and soon to be eclipsed again by our planet. Where are you? It'll be here. There it is. So, as we see it go around our horizon, we can see that it's half in day, half in night. It might be tidally locked with ours, but we will eventually get blocked out by the sun, and we see a nice red glow. and then we get some light back. But you are certainly free to explore anything that you can possibly land on. We can... There it goes again. Sorry, sometimes it just leaves you speechless in VR, it really does. Sometimes we can find elements and minerals. If we remember what was viable on this system. Oops. If I bring it up, if I can actually stop first. And if I bring up our surface map, well, we can see where we are exactly. We can see where a point of interest is with, it seems like, an installation that somebody has already settled or colonized. And you can see the light dark horizon that runs down through the center of this moon. There seems to be a polar ice cap up at the very top. Seems to be another ice cap at the very bottom. But there we are, right there. Now for us, we have the ability on this particular moon to mine iron, sulfur, nickel, carbon, chromium, and we can always sell it for a profit. Or niobium, cadmium, tellurium, zirconium. All of these things are certainly possible. Okay, we're still tidally locked. Very, very canted at 24 degrees. Orbital inclination is pretty well close to 360. And every other possible thing that you could think about when it comes to astrophysics or planetary motion. So you could easily incorporate basic laws of physics, Kepler's laws of planetary motion, any geological features, understanding surface temperatures with Kelvin. You could find out if this is a viable place for someone to live. Would this work out well? Would you be able to sleep with something flying around on the sky every 30 seconds? I'm not sure if I could. But if we wanted to see our crater is just ahead. And we can certainly investigate craters. However, it would be very wise to not fall down this crater because it's going to be very hard to get back up. It looked very, very deep. But as you can see, as modeled, I don't want to go any further. If we slide down, we're not going to be able to get back up. If we remember from out in space, there goes the planet again. This crater was accurately modeled in size and shape, and we could certainly go down to the very bottom. We could certainly take some samples. We could analyze them for science. We could go around the outside edge, and I could show you the relative size of it, but it's not in the time frame that we have today. So what instead I'm going to do is actually return to where I started at the Miller Depot. But first we have to get back in our ship. The only reason I'm going slow, if you remember, we have 0.09 times the amount of gravity, so we are very, very, very light right now. So if I go fast, there's a chance I could flip over or lose control. And we certainly don't want that. So we definitely want to board our ship again. And we will come back up. And now we're back to where we started. I will launch, and then we will plot our course to return back to our home. So we're going to hold R, we're going to launch and detach from the surface. Move vertical. As we leave the surface, we can certainly tip. Just make sure don't have any forward velocity if you do. See, we are approximately 800 meters above the surface right now. But we certainly want to leave. So I want to increase my inclination angle. Retract landing gear.
Landing gear retracted.
Currently we're escaping at 37 degrees, and we are not mass locked anymore, so that means that I can move out of here pretty quickly.
Frameshift drive charging.
You need to make sure you align with escape vectors, so that way you can leave gravity. And now we're able to move quicker. As long as we miss our planet. That would not be fun. To go from one moon to crash into a planet. As you can see, we're leaving our surface. I'm going to roll left. VR users, be aware. Still increasing away, but now we're inverted. And you can see that we still have defining characteristics of our moon that are able to be future places to land. But not today. So we are going to return to base. Oops, wrong button. If I can remember how to get out of here. There we go. Okay.
Frameshift drive charging. 4, 3, 2, 1. Engage.
As it is, we're still trying to leave these planetary bodies gravitational influence. So we're still 120 kilometers above the surface, 150. If you remember, the moon said it had no atmosphere, even though it still has influence over how you escape. There we are. Okay, so now we're able to increase velocity, and we'll be able to return home. Definitely want to move away. There's a beautiful nebula over there on port. And we want to return to where we started. So I want to open up my galaxy map, which has our star clusters available. And we were actually south at Barnard's star. And it should be a 2-system jump. Yep, we have to go through Ross 154 again, which we will do once I bring it about. Currently we're headed a little bit off course, so I have to come about. And Ross 54 is located in this direction. There are celestial navigational markers, and everything in here is modeled correctly. I'm not very up on my celestial navigation.
Frameshift drive charging.
But if I remember right, it is a system of 2 numbers. The ship's computer does everything for you. It's pretty nice.
4, 3, 2, 1.
Now we're at Ross 154. We have one more jump to go.
Fuel scooping.
Oh, that is also a supplementary science lesson. So certain stars out of the star classification system actually give off hydrogen gas as a byproduct of solar wind. So one of the fictionalized sources of energy in this program is to use hydrogen fuel scoops from stars. So you can learn different star classifications just by stopping off and getting some space gas. It's pretty nice. Okay, now we're in alignment with Barnard's star, and we'll make sure we jump to this. Of course, it's still 5.5 light years away, so if I wanted to, we could certainly take 110 days in the sim to get there, but of course it's just nice to have a warp drive.
2, 1,
And then the wow factor as we move through space is just... there's nothing else like it other than actually doing it. Okay. So now we're finally at our home star again. Barnard's star. Similar to ours. Just a little bit smaller. And what I'm looking for is the Miller Depot, which should be right there. Okay, 45 light seconds away. So I want to lock destination, and in my little virtual reality display that you see up there on the left is actually an orbital space station, and it's telling me that it's directly aft. So we are going to come about, moving within our solar system, and the Miller Depot is now straight ahead. Looks like we are coming either directly above or directly below the orbital inclination of this star system, as you can see, because it's starting to flatten out as we get closer. And it looks like we are on the third orbital as it is. So there would be number 1 right there, number 2, and now we're on the third orbital, which should be the third planet. And then our station is rotating around the third planet. So the third planet of this system is actually that little shiny dot, and then our orbital pattern is the circle that we need to find. It's hard to control a space station sometimes. And we overshot it. It's sometimes hard to get it right, but it's okay. You can always come about and try again. Only 5 megameters away from it. I'm going to bring it about so that way we're not rotating so bad. Kind of unusual. You have to keep your hand on the throttle when it comes to visiting space stations. They're kind of tricky to get to because they're actively orbiting planets. So if you come back to Miller Depot a week from now, it will be in a different location around the planet than it was today. And here we are. So I'm going to come to a full stop. And now we're back to where we returned, except I would like to land. So this is actually a secondary challenge when it comes to spatial abilities in flight simulators, is that this depot is actually actively rotating. And now you need to be able to actively rotate with it in order to enter the station. So in this particular sim, the first thing I need to do, always be polite and ask for permission to land. So we are going to approach radio contact, which is right now. Miller Depot. Looks like we have 2 friendlies in the area, and request docking.
Request approved. Set down on landing pad 30.
So now I have approximately 10 minutes now that they have cleared, I don't want to call it airspace, but now that they have cleared space in order for me to safely land at pad 30, along with other users who may be in the area, and it looks like there are several. So, as I approach, we certainly don't want to speed. And we are going to safely re-enter this space station.
Attention. Reduce speed to 100.
Yes, sir. It looks like we still have advertising even in outer space. So there looks like there's 6 holographic images that are advertising the latest and greatest of whatever's happening in year 3300. Make sure we come about. Reduce speed a little bit.
Scan detected.
2,000 meters from touchdown.
And now we have entered the space station. Now the new challenge is, where is your docking station? Because it looks like if I were to come to a full stop, which is probably not good etiquette right now, but I'm going to anyway. Looks like dock 16 is down below. Dock 08. Yep. Now they're yelling at me. And it looks like dock 30 is now straight ahead, so I have to invert. And come about safely. Looks like we have a observational tower in the way. Make sure you don't hit it. And I need to make sure my landing gear is deployed. There we go. And we still have 7.5 minutes, so you can certainly take your time.
Landing gear deployed.
This is a flight regulations reminder. Please do not obstruct the access corridor during arrival and departure. Thank you and enjoy the stay.
And then as we come in, gives us a nice little target. And there we're centered on the pad, so I can bring it level to a full stop and then straight down. Oop, a little bit too far. There we are. And straight down again.
Touchdown confirmed. Docking restraints engaged. Report to station services for more information, Commander.
And now you can see we're back to where we started. So that's essentially the space simulator. Elite Dangerous is wonderful because it accurately, as far as we can tell, and as far as we know, everything about the Milky Way galaxy is reimagined in this simulator. So I can visit everything in our solar system. I can find Voyager 1 and Voyager 2. They are accurately located in the simulator just outside the solar system. We can also, I just learned last week, find the golden record that was on Voyager 1 from Carl Sagan. So everything that is possible has been reimagined in this simulator, and it always constantly gets improved and becomes better and better because it's been around since 1984. So we are now at 36 years of replicating the Milky Way galaxy in computers, which is wonderful because it just gets better and better as the advent of virtual reality just comes along more and more. And quite honestly, it's fairly addictive. I've always gone outside and just looked at the stars and said, I wonder what it would be like to visit those. And the wonderful thing is that if I get close enough, now that I'm thinking about it, in my galaxy map, back to the original Milky Way, if I get close enough to the Sol, which is right here, our solar system, if I look out into the distance, there's some faint white lines, and those are actually the appropriate constellations that you would see in the night sky. So There's the appropriate Barnard's Loop, the Orion Nebula. We have the Corset Nebula, the Polaris. So the North Star is straight up north. Alioth. Every constellation that is possible to be seen is also modeled in our galaxy map. The Coalsack Nebula region, there's Sagittarius A, we've already seen that. The Elephant's Trunk Nebula, North America Nebula. There's a California, there it is, California Nebula. So they're all certainly possible. And you can locate, enjoy, find everything that you want. I can find black holes in Sagittarius A. I can find pulsars. I can find Sirius, which, if I run over to it real quick, while I have a couple minutes, it is a Class A star, which is why it is blue. It is very, very, very hot. And according to this, you need a special permit in order to get to it. So you have to unlock certain things in order to see them. That's not true in free play. That is essentially the entirety of the Milky Way as we know it, replicated for anyone to use. And you can explore everything that is possible in this galaxy as we know it and as we learn it. So, thank you very much.